Okay, so today we're going to look at the last coding challenge in chapter 4. It's 4.11. So, rectangle intersection. Cool. This is a fun little exercise where we have two rectangles. So this is A, this guy is B. Right. So here we have an X and this guy is Y. So this is X for the B and Y for the B. And what we're looking for is this square, right? So our point is here for X and Y. And of course, we need to calculate width and height. Okay. So as we see here, the X and Y is basically the max between those two guys, right? And the max between those two guys are our coordinates for the new rectangle. And the width, height, we need to take, I think it's, so y plus width minus, okay, yeah. So yeah, we will see this in code. Let's talk about time space complexity. It's basically just a few functions. So both time and space are of 1, I believe. Yeah. We're not allocating any new memory. Calculations are straightforward, so yeah. Let's implement this. Def intersection. Say R1, R2. Okay. So first we need to check if we actually have an intersection. If we have two rectangles that are far apart, we don't have any intersection, right? So we'll have helper function if is actually intersection for those two rectangles. Oh, if it's not, yeah, we just return, right? If not, we negate this. And we pass both rectangles. And if we don't have intersection, we can return whatever. Like in this case, we will just return angle with 0, 0 coordinates, and width is -1 and height is -1 as well. So once we're on this line of code, we have an intersection. So we need to just, this is our helper. We will implement this later. Cool. And now we need to calculate X, Y, width, and height, right? And once we have these guys, we can just return the new rectangle with these values. Okay, so X and Y is just max between R1X and R2X. Y is the same, so max R1 and R2Y. But for width, as we see, we need to always take the smaller rectangle, right? So the minimum between r1x plus r1 width. Right, so we get a smaller rectangle, r2x, r2 width. So once we get a smaller amount, we just reduce it. See here, we get this guy, and then we need to reduce it by the max of those two guys here, right? Which we already have here, max between those two axes. Okay, and for the height, it's basically the same, just we flip x and y and width with height. So r1y plus r1 plus r2 height, that's y. Cool. And we just return the new rectangle with x, y, and height. And that's it. The implementation of this we can see in the code. I'm not going to write it right here. Yeah, let's write it in code and see if all the test cases pass. Right, so here we have our rectangle class or name tuple, which we can use. So if right, let's just so both for x and y, we just bring down the maximum values for those two rectangles. Minus maximum value for the axis, right? Sorry for not commenting this because like I need to focus so the code is right. Okay, so as we said, we get those two values to get a rectangle. Let's see if this code looks right. At the intersection, we will be implementing this shortly. So for max values, mean looks good. Width, we get a minimum value for those two sides. That's good. Minus x, which is max between these two values, and here's the same. That looks good. Let's just implement this function. R2, just basically return. So we need to check, just look here. How do we know if there's intersection? So basically both points need to be less than the side, right? Is this correct? Yeah. Okay. So let's say we have r1x needs to be less than r2.x plus r2 dot right? other guy. R1.y is less than R2.y plus R2 dot. Okay. Oh, and I think it should be equals. Like, it depends on the interviewer, but if this is intersection, but in this case, I think we need to do that. Let's just run the code, and all the test cases pass, so this is good. Okay, that's all for today, and until next time, bye.